All right, you can see 13 through 16 is the difference of two squares, and 17 through 20 is a sum or difference of cubes. Okay, so 17 through 20 is the difference of two squares. So there's virtually no work to do with these. Is you just have to figure out what are the two pieces that's being squared. Okay, now normally these are just going to be squared. Okay, sometimes they're to the fourth power. If you notice in your homework, it was a little bit more difficult. Maybe it was 4a to the fourth, and then you had to figure out that it was 2a to the second that was being squared. But not for here. Okay. So the difference of two squares looks like that would be 2a and this would be 5, okay? Now, what I noticed in you guys' homework is you guys just wrote 2a plus 5 and then went to the next one, okay? Whenever you factor the difference of two squares, you need to have the second parenthesis, okay? So make sure that you do write the second one. Now, this guy can go first. Just make sure that you write this guy second. So there's got to be two parentheses. And some of you, which I thought was very clever, actually, you did that. And I thought, like, oh, they're using a piece of the quadratic formula to kind of show that it's both. And that's cool. I thought that was, man, I actually never seen that before. So that was kind of just really clever. But you just, you don't do it, even though it is clever. All right. Okay, so now in 18, 125 is not a perfect square, and neither is 45. So make sure you do a GCF. Now, GCF is the greatest common factor. Now, it looks like here, you can see in your choices, do you see how they pulled out a 5? We're going to pull a 5 out of these guys to see if there's actually a perfect square that's left. So 5 goes into 125 25 times, and it goes into 9 once. So now, by taking out the 5, we have a difference of two squares now. So this right here is a 5x, and that would be a 3. So the difference of two squares rule says that I got 5x. Let's do minus first. Why not? And then we'll do 5x plus 3 secondly. And that's it. What is that? That's b. Okay? So if you had to freestyle, this guy is 4v plus 1 and 4v minus 1. 1 and 64 are one of the nice ones, which are both squares and cubes. So be careful with that. This guy probably needs a common factor pulled out. You can at least take out a 2. So that's 25n squared minus 4, which gives us perfect square here and perfect square there. Perfect. So 2, 5n minus 2, and 5n plus 2. All right, that's it. So now we get to cubes, and you need the rules. Okay, the rules. So make sure you write these rules on your study guide. Okay, so go look through your notes. I'm not going to write them out here. I'm going to assume that you have access to them. Okay, I have them memorized. I know which one's being cubed. Okay, so this guy is being cubed. That is 5 to the third power. 27 is actually 3 to the third power, and x to the third power. That would just be an x. So looks like I have a 5 and a 3x. Now this is a sum formula. So I'm going to have 5 plus 3x as my first parenthesis. I noticed a lot of you guys, you did the digital ones correct, but you didn't do the, and a lot of your digital ones made the same mistake too. So I don't know if you guys are copying. I think that's a really bad idea for the digital stuff, because you really want to do those, not to get them done, but to check your answers, okay? Because what we need in the second parenthesis are 3 terms. That's what the rule states, okay? It's going to be on the SAT. I almost guarantee it. So that formula tells you that you're supposed to square the first one, then multiply the 2 together. Okay, these 2 multiplied to each other equals that. And then you square the second one, so or the second one here for 9x squared. Okay, and that's it. However, I did mess up though, because the rule also says that this guy should be negative no matter what. Okay, this guy has to be negative. So your answer here is E. Okay, that's just the rule. Okay, over here we've got 3 being cubed, and then this is a 5 5a. Okay, so kind of similar to 21, but it's not. So we get 3 minus 5a. Okay, because if it's minus here, it'll be minus here. So then we follow the rule. It says you're going to square it, multiply the two together, but now it's going to be positive, and then you're going to square the last term. Okay, and it looks like that is going to be a. All right, so don't make those any harder than they need to be. Okay, this right here to the third power, that's a 3. This guy is a 4 and an x. It is the sum formula. So we got 4x plus 3. Notice that there's no work to do here. Oh shoot. Looks like the low battery thing came on and might have stopped the recording there for a second. We'll see. All right, so with the sum, now we're going to square this guy. Then it goes minus, those two multiplied to each other. And then we square the last term. Okay? Oh, square. All right, final answer. So here's 1, and then this is actually 6 to the third power, x. So we've got 1 minus 6x. And then we're going to go 1 squared is 1 plus 6x times 1. And then we simply square 6x. Okay? So again, I'm not doing any work with these. I'm just following the formula, and it should be really just knocked out quickly. Okay?